Today we are going to work on the lead code problem path sum. So this problem is a common Amazon coding interview question, and in this problem you'll be given the root of a binary tree and you'll be given a target sum. So we need to return true if there's a path where from the root to one of its leaves, the sum of all of that adds up to the target sum. So yeah, here's an example where they've given a tree and they've given a value of 22. So if we go down this path 5, 4, 11 and 2, there's a path where all the way from the root to all the way to its leaves, the path value is equal to the target sum. So yeah, this question usually is asked during for the phone interview for screening the candidates. And I find a lot of the mistake the candidates do is that they don't check if it's a leaf node. So they'll calculate the path, and whenever it hits the target, I think they say it returns true, and without realizing that the problem asked them to go all the way to one of the leaves. So yeah, the way to solve this problem, usually any problem which involves a binary tree will require some sort of recursion to solve it. So yeah, the way we'll solve it is we'll always calculate the sum at each of the nodes, and then we'll keep traversing left and right and keep adding the sum, and we'll keep comparing it to the target sum. If you have reached all the way to the end, to the leaves of the binary tree, we'll make sure that you have calculated the current sum and compare it to see that if the values will match. So yeah, let's try solving it. So before that, I'll just create a Boolean method to check if it's a leaf node. So this is a helper method we'll use just to make sure we have reached all the way to the end of the binary tree. And yeah, for calling a recursive function, we'll create a new method. So let's call it private. Oops. And here we'll pass a new parameter called current sum. So this is the one we'll keep track of what the value is at that particular node. So here for calling it, we'll first, just call the recursive function. So we'll pass the root, target sum, and 0 because we are just starting out. So for all recursive functions, we need a base case and a recursive case. So here the base case is we have reached all the way to the end and we haven't found a path with the target sum. In that case, we return false. So if so that's a base case. Now for the another case we have to look is it possible where we have reached all the way to the leaf node and the value is equal to the target sum. So if and current sum plus actually. So in that case, we return true. Else, we are now going to recursively call the left and right child of that tree, and we'll keep comparing the values. So return as. Before that, I'll just add a new integer, new sum. So we say has path sum, and we just pass the root dot left and right. Yes. So to recap, we are using a recursive solution. At each point, we are just going to calculate the current sum and use it to compare it to the target sum to ensure we have reached all the way to the end of the tree and we have reached the current value that we want. So yeah, the base case is if we have reached all the way to the end where the root is null and the value is not equal to the target sum, then we return false. So that's why we have this check. If it is a leaf node and the value is equal to the target sum, we return true. Else we recursively call the left and right child and keep traversing down the tree. So yeah, let's try running the solution. So all the three use cases are passed. We'll try submitting it. So yeah, the time complexity for this is O of n, where n is the number of nodes in the binary tree. And the space complexity will be O of n, where n is the depth of the tree. So because we're calling a recursive function, each function has to wait for the other functions to return the result. So we'll have the memory storage of that node in the stack. So yeah, that's why the memory complexity is O of n.